Hello, tech enthusiast. Welcome to my channel. My name is Viren. I've been working in technology space for more than 18 years now. And throughout my career, I've had the privilege of witnessing the birth of new paradigms. And many a times I've been instrumental in encouraging companies to embrace the transformative power of the innovations, especially in the technological space. My hobby is to dissect the emerging technologies, and hence I'm really excited to bring my vast experience to you via this YouTube channel. So today we're going to start our journey with a well-known tool in the market called Databricks. I call it decoding Databricks because we're going to go bottom of the tool, what it stands for. So let's start right away. Um, so Databricks is another tool that allows you to connect your sources of data to one platform. It allows you to store the data, transform the data, allows you to analyze the data. You can model it the way you want, and supply that data to the different tools around, such as business intelligence tools or advanced artificial intelligence tools as well. So, in simple terms, right, it's basically a ETL tool. However, based on the file system, we'll see what that system stands for, and it allows you to get that data, store the data, process, load it further, and if you want to send it across to, say, machine learning platform or a hyperscaler services, you can do so. Now, next, the other important thing I would like to focus on is the Databricks journey. So, the another point I would like to focus on is the Databricks journey, uh, because I think history is important to understand what. Another point I would like to focus on is the Databricks journey, uh, because I think history is important to understand what tool is about, where it comes from, and where it wants to go. So the Databricks was it grew out of a AMP lab project in University of California. There were seven individuals who set up this company with a CEO Ali there, and once they had a basic product, what they started doing is, just like any other company in the market, they started integrating with the hyperscalers because AWS, Azure, GCP being the most important players in the market. It's always important to integrate with those all the services that they have so that your existing infrastructure perfectly aligns and integrates with what is coming new, what is going to be brought by Databricks newly. So 15, 17, and 21 year was focused towards those integrations. Then they started acquiring the companies because you have a core product, but you also want to improve and make that to make an improvement. Sometimes inorganic growth is the way to go. So they acquired Red Dash to give them a capability of SQL visualizations. You can just drag and drop and it creates nice visualizations, charts, whatever it you may want based on a simple drag and drop in SQL user interface. Then they acquired a German company called 8080 Labs, who has, maybe you have heard that, it's a well-known tool called Bamboo. It also allows, it's a no-code platform, so it also allows you with a simple drag and drop and user behaviors, convert that into the Python code. Comes very handy for the developers, right? And then because there is a big buzz around uh, as we know, the language tools like LLMs, they created a new language model called Dolly, However, there are not that many parameters available in the market of evaluation. However, I'm going to keep an eye on that down the line. Then they acquired recently something around data governance and data replication space as well. Having said that about background and what it stands for as a tool, let's really focus on the technology evaluation, because I feel before I jump into what technology it uses, we need to really understand what encouraged them to be there, because otherwise it's just hard to sell any tool in the market if you are not unique in what you're offering. So I'm pretty sure this evaluation will help you to understand why they did what they did. So as we know, we have been using classical databases, row columnar databases. You have nice tables in IBM tools, Oracle tools, or even SAP has its own HANA columnar database there. You store data in very structured and appropriate format the way you want, and then you supply it to your business intelligence, sorry, the reporting tools as we call. And all is well, fits perfect. However, this all the time does not quite work. Like, just to kind of simply explain, yeah, like we all know, right? DB tables are simple tables. You have sales order as an example here. I've drawn one simple table where you have a sales order, you have a customer, you have a date, your quantity, price per unit. You can add anything you like. And this is a very precise, prescribed format. It's not going to change. It's not going to allow you to change that easily, especially when you have data inside it. And it's kind of going to be, let's say, pretty much a standard format for that particular table for you. And what would generally happen is it was fine for that time point in time. However, what happened is eventually there has been an introduction of lots of new technologies, right? IoT, uh, again, there was something around artificial intelligence, and has been a lot of data, structured and unstructured. Again, from AI ML standpoint, machine learning standpoint, you want to analyze huge history of the data. You have billions of records to come up with the ideal machine learning models and give you predictions sometimes. So for all such scenarios, the classical platforms were not capable enough. You cannot just go and install Python and R libraries on those platforms and start pulling data and working on that. So considering all these facts, amount of data, the new technologies in AI ML, there was an obvious trend of moving towards data lake. However, data lake sounded fine, it worked fine, but in data lake, you're always dealing with flat files. We'll see what that means in subsequent slides. And dealing with flat files is not as easy as dealing with tables or views for that matter. And hence, there was a concept of delta lake introduced. Uh, and Databricks did nothing but uses delta lake underneath. Now, uh, if we move to the maybe next slide, uh, what we see here is we are going to focus on what classical database limitations are. I'm just going to quickly brush up on them just so that you know, like I said, why Databricks or data lake was needed. uh, at the start, like I mentioned, unstructured data is not a cup of tea for the structured databases. You have a table, you cannot just go and put various different unstructured data sets there. Like here, you have text files, you have servers, website logs, you have lots of sensory data. You could be having images, you could be having video files, it could be even audio files, and not necessarily that you're always going to get the same structure around it. So that was the most problematic part on behalf of classical databases. Then, classically, there is always a trend towards layering the data in the system. You have a basic layer where you store the data, then you would like to transform it to the different requirements. You keep transforming one layer up and up until the data reaches to the users. And this all additional storage of the data in between tables causes a long time before the data really appears to the users, which is also something that you would want to improve on. Then, like I said, AI ML support is not that easy because those new libraries or new programming, open source programming languages are not that easy to be installed on the existing platforms or the infrastructure that you have. So there is always a need to push the data out because you just cannot achieve it in your existing system. Scalability, I think more or you'll and would understand what scalability means. However, generally scalability can range from horizontal scaling, and there could be a vertical scaling, right? Um, you would like to add number of machines in your infrastructure when your workload is increasing. It's like adding additional computer next to your computer to just make a lot of work in parallel. In vertical scaling, you're adding additional memory. It's like adding additional memory in your laptop as and when you need, and you reduce it back when you don't need. So it's one side additional machine, or other side is additional memory in the same machine. And all that random dynamic interchange is not that easy in the classical databases, which were most of the times were on premise. Then there is always a problem with a lot of those tools where there is a proprietary format created. In SAS, you have SAS 7B DAT format, or in some cases, SAP also has some of their own proprietary formats to pull the data out or to read the data. And all that makes it a bit more inflexible for other systems to read the data and process the data around it. Hence, there was a rise of data lake concept. So what they say, you know what? I'm gonna store everything as a flat file, and in the in kind of a flat file format, or it could be any format. Yeah, it could be JSON, it could be CSV, it could be anything. And once you store that data as a file, I'm going to process that data out. So that way, what happens is there is additional supportability of unstructured data, and you can have processed a huge amount of data in one go. So imagine in our previous example where we said, you know what, I have a table where which has a structure. But now there could be a scenario if I want to process the same data in a matter of flat file, what would I do? It would something look like this. So here also, consider this is a CSV file, right? I think we all know what CSV stands for. There is a sales order, customer, date, quantity, price per unit, and the values around it. It's a comma separated by comma here. And you keep getting those new additional data in a form of file, and you're going to keep storing that, and then you're going to keep using it for further usage, for example analytics or AI ML. So this kind of started picking up a few years back, and it was also quite useful in a sense because you are getting access to the huge data, although it's a file, but you are storing all data together in, say, a simple storage on hyperscalers like AWS, Google, or GCP. But as we uh, all have seen probably, or you heard, there had been a lot of challenges processing these file-based platforms. For example, let me pull it up just for easier understanding. Is imagine you are trying to do create operation, or as an example, you are trying to modify a record, say sales record, a sales order S1. In our example, you would like to change the value of this of the sales order to some the quantity of the sales order to something else. That is not that easy when it comes to the files, because you're talking about a file, you're not talking about a particular key of a table that you can go and just right away start changing or updating it. Hence, all the crude operations around the files is never been that easy when it comes to data lake. All the ACID transactions, like imagine you are loading the data all the time in terms of files. So in our example, let's say you have a file number one here. This is a file number one, which is processing for 10th January. And there is a file number two, which is 11th January. Imagine when we are loading the data into our system, we are loading these two files and one file fails. Now, it is important that the same file, only the file which is failed is pre-processed, not everything, because you otherwise you're gonna have just duplicates for simple S1 order, which means your quantities are gonna duplicate, your price is gonna duplicate, and that kind of control over files is not that easy, because imagine here you do not have keys for the file, and then it's hard to keep track of those files. At the same time, imagine you are trying to write this file here. Maybe let me use a pointer. Imagine you are trying to process this file, and uh, and you would like to also read data at the same time. There would be a lot of confusion towards what kind of data we are getting and what we are not getting. It could also happen that there is some failure while loading this file, or some other program is loading or changing this file. So when you're reading and writing data simultaneously, it's never a pleasant story. So the flat files also do not support versioning, history, or time travel. For understanding purpose, let's see what all these concepts really mean. They sound really fascinating, but let's see what really they mean by that. So consider you have a versioning as example. That firstly, there was one file that came for this sales order, two sales orders on 10th uh, uh, January with certain quantity and price. But then after let's say 2 hours, there is another file that came with a different quantity and price per unit, because someone thought, okay, there was a mistake, I would like to load it again. That means you have two versions of the same file or a same data. And tomorrow, if I want to go and check uh, what was the versioning of my data, all historical ones, I should be able to easily do that when it comes to. So if I go and say, okay, give me version 1 of S1 order, what was the value? Give me version 2 of S1 order, what was the value of quantity there? So that kind of comfortness wouldn't be there when it comes to the files versus in databases. You are always able to store the historical values in terms of a table. You can also store the old versions of the records as well. Now, if you twist this and say, you know what, it's not about version, but I would like to see how was the value, what was the value of these sales orders at 9 a.m. here, like you said. And someone wants to say, okay, what was the value at 10 a.m.? And this kind of traceability should also be there. And that's what I mean by time travel feature. Such features are not that easy to achieve, because many a times these features are drivers for auditing purpose. Hence, files have that kind of limitation. Then there is a case of delta architecture, like because you do not have keys of of a particular file. Like in that case, there was a key of sales order number in table, but in files it was not there. So it's hard to really figure out what you're going to duplicate, what you're going to add, what you're going to append or insert in the table. And at the same time, it's very important that same file is not processed twice from a file perspective. And that kind of architecture is also not that easy to implement. GDPR support. Maybe you have heard I think a couple of years ago there was a law about making sure that if certain vendors or customers or people, any personal data, if that person doesn't want to share with others, that needs to be removed from your internal system as well, or at least should not be made visible to anyone. And if that such request comes, you should be able to easily remove certain record as and when required. So as an example here, you see there is a C1 customer, and if C1 customer tomorrow comes and says, I cannot, I do not want to store your data, my data to your system, and I should be able to right away go delete all the records for C1 from all the systems. And that feature is also not that easy to achieve. There is another aspect, because you are dealing with flat files, you cannot read the data that efficiently because you have a bunch of files and you're trying to read out of it. It's never going to be that easy. And same, that's what we do in analytics. Analytics, we try to read all the data, and the performance will never be as at par because you have a bunch of files. You just have to process so much data in one go before you show the data, because you also don't have structure available. So it's never going to be that easy as a classical database. Hence, there was emergence of a delta lake concept. You know what they said? You have cons in both of those old classical DB and data lake. Let's create something that mixes the pros of both of them to make a product that perfectly fits and has a less cons as outcome of it. So what they said, you know what they said? I have a at the bottom something called data lake files that acts as my let's say database in this case, and on the top you're going to create something called classical table structures. So you have an advantage of data lake, which it comes to files, because you're going to quickly load the data, you're going to store very efficiently, you're able to compress the data as well efficiently because you're storing as a file. But at the same time, you're not going to losing out on the advantage, because on the top, as from a user standpoint or from a processing standpoint or from a reporting standpoint, you have a table. And that's what Delta Lake did. They created a very intelligent mechanism to do that exactly. So if we maybe focus on back to our example, where if I want to just convert to what I was telling you, is best of both worlds. That's the correct phrase here. So you have a file 1 for S1, S2, and you have file 2 for S3 and S4 sales orders. And that's acting as a data lake file system that I was showing in the architecture diagram. And on the top, what it looks like is as if the data is in the table format. So for me, it doesn't matter how data is stored in the behind, but I am seeing it as if it's all view or a table, structured data. And that's what they tried to do it. Now one would wonder how, because it's not uh, it's not easy really to just use a table on top of file and say okay, it is done. No, that's what that's where what they did is they created something called Delta Lake architecture, as I was saying. So anything that you're going to store is going to be stored as a Parquet file. It doesn't create anything different. So it's going to create a Parquet file there. It's going to store the data as a file. You can store it in Amazon. You can store it in Google, GCP, Azure, or any other storage as you like. And on top of that, What they did is they created a what I call as a Delta Lake magical layer, or it's basically a virtual layer. So this layer basically does all the legwork of converting a file data into a tabular or a structured data to the end users. It also helps you to create all the crude options, acid options, or versioning, all the problems that you had seen in the data lake, sorry, they will be resolved in here. But it would be interesting. How do they do that? Because at the end, what they're doing is Parquet files, magical layer, and suddenly you have a delta table data, which gives you a structure to the data. It also gives you a lot of security and authorization advantages as well. So let's go back to the example here, how really it on the ground works. This is going to take a bit longer because this is the most important part of Databricks, how they really function from the code. So imagine you have a simple data for visualization. I've created this table. In case of Databricks, I failed to mention they call it as a delta table. So this is considered as a delta table, which is created based on a simple data lake files. In this case, Parquet files. By the way, Parquet files is one of the file format which is a columnar, and it has a high capacity to compressed data. That means reducing the file size, and it also supports you to read the data fast. So it has best of all possible things that you would like from a file format, and that's why Databricks chose Parquet file as a file format. So imagine you have a table which is based on a Parquet files, and it looks like somehow like this: S1, S2, S3, S4. You have four sales orders, just like what we saw before, and you have a magical layer in between. And what you're trying to do now as operation is you're gonna just try to insert one record. So let's say I want to insert a record, maybe maximize. I'm trying to insert S5 sales order here. Now, see, I'm writing a SQL query here, right? I'm not doing any file load or as such. So what I'm setting in SQL query, you'll also see, we'll also talk about that SQL interface little later, is I'm going to insert into this table S5 order with certain of these attributes ahead and the values of KPIs. And as soon as I say that, okay, I'm going to insert the data, what it is doing, it is creating in behind, yeah, two files. One is a Parquet file, like we talked about, and there is another called JSON file. The Parquet file basically stores the values that you would like to write into the system, yeah, or into the, in this case, let's call it a database, yeah, for simple understanding. So here you have S5 order, all these values are available here, yeah. Then you also have another file created which is called a JSON file. What it basically does, it keeps a track of all the operations that you would like to do on the database. So in this case, I'm trying to insert. So the operation is insert. And what it says to the system or to the magical layer is that I need to add file1 Parquet file into the system. So this is a Parquet file 1, just for clarification. So basically what happens is when the table is run, let's say tomorrow I'm going to go and write a select statement on top of that and say, you know what, I want data, all the data. And it needs to pull S1 to S5, right? In simple terms, because S5 is inserted. So what it does is when I'm trying to load the data or visualize the data as a user, it goes through this magical layer. It goes through this transactional log and it says, oh, I have to add one file, which is this file. So what's it going to do? It's going to merge a file of S5 with the files of S1 to S4, the files we saw above, yeah, that we were trying to load. So it's going to merge this file and this file and gonna show you the data. So at the end, when you see the data, you know what, how it's gonna look? Uh, it's gonna C3, 10, 0, 1, 2, 4, 3, and 530, and it's gonna be 40 euros. So as you see, it's gonna, when I write a select statement on top of that, it's gonna pull all this data right away. Now, it would be interesting to see how it will react when the next operation comes. For example, I'm now going to modify the data. So here, let's say update table is a SQL statement. What I would like to do is update the quantity of S5 to 340. Very simple operation in SQL world. And ideally what it will now in this case, what it will do is it is again going to create another log file and another Parquet file. It's going to keep creating the Parquet files. So as an example, here it created so Parquet file 1. You see, this is the old value 530, and it created another file which is a 340. So this was already there, right? This one was already there, and what it created is an additional file called file 2. And in the logs of JSON file, what it said, operation delete and remove file 1 because this 530 is no longer applicable, but insert and add file 2, which means remove all the data of this, as in don't consider this file and consider only this file. That means my values are going to be updated very easily. So here, this will become, when I read the data, it's going to become 340. As simple as that. Now, if you want to try to delete the data, so for example, you are trying to delete from table 1 again, the S5 order. What it should be doing, or it would be doing, is creating another transactional log. Here it is still file 1. Maybe it should be also file 2 because we also changed the value, right? So I would put that additional file 2 as well. Let me copy the text also here. I see. You see, this is going to be the file 1, file 2. Yeah, this was a file 2 Parquet file, and ideally this should have been the value of 340, right? That's what we updated. Now what it will do is basically it's going to keep the file 1, file 2 as it is, but what it's going to do is it in the operations it is going to write remove. Operation delete means remove file 1 Parquet and file 2 Parquet. So when the data is read in the report, what it's going to do is going to skip these two files and completely get rid of this record. So uh, so what it will basically do is it keeps piling up like this. It keeps piling up like this. It keeps creating the files. It keeps creating the logs, and you have a bunch of whole data sets in the system then. Now, as you can see, it's huge number of files, and the system has to process it. And while to process it in most accelerated manner, what they did is they deployed something called Spark architecture. So what basically Spark does, it's a distributed computing platform or in-memory engine, which simply works on divide and conquer rule. That is, it divides all the workload into multiple nodes of the CPUs, and that's where I was talking about horizontal scaling or virtual or a vertical scaling, that it automatically picks up the memory that it needs, the processing capacity that it needs, and pulls real time from the files. And it is quite efficient to do the job in pretty challenging timelines. So to summarize, you have, say, as an example, you have a BI query. Let's say you have Tableau on top of it or SQL on top of it. You're trying to write something into the system. This request comes down. Spark sends it down to Delta table. Delta table sends it to the Delta Lake layer to process it, and it Delta Lake layer creates all the logs that I was talking about. Yeah, the JSON file logs that we saw in the example, and it also creates a data parquet file that we saw in the example. And whenever tomorrow BI or SQL says select statement, I would like to read data for say 2024. What it does, it again goes down. It reads from this transactional log, all the log, to understand which files to read, which not to take, how to read, from where? From this Parquet files storage, and supply the data out. So it's quite efficient a system that they have designed, and it works quite well. I've seen with lots of customers. And here in the Delta table space, I forgot to mention, it also gives you a possibility to set the authorizations. Like, let's say a regional manager of Europe should not be able to see the data of North America. All such authorizations can be set on top of the Delta table because it's giving you structure on top of the files, which was not that easy to achieve when it was directly were doing on files, the authorization setup, I mean. So all in all, this setup works quite efficiently with the help of course, Apache Spark architecture, and as I call Delta Lake, a magical layer that they have designed there. Now the obvious question comes that, are we not storing data multiple times? Because I also said that, in layered architecture it takes long time to load the data till it reaches and is visible to the users. So in this case also, there is a layered architecture. Like you said, it's a bronze, silver, gold architecture, which layers, which does, as the name suggests, you in bronze you have a raw ingestion layer. Your data remains as it is. In silver, you are filtering the data, cleaning the data. Maybe you want to remove some prefixes, suffixes, or you have some extra characters that you want to get rid of. You can do that. And then there is a gold layer, which is a simple business focused layer by combining multiple silver layers and get the data exactly what that matters to the business. However, like I said, although it is a layered architecture, and Databricks calls it as a medallion architecture, you are you have an option not to store the data here. So this all can be just views. So any transformations or any activities that you would like to do, that can stay that can happen without storing the data, which is what allows you to make that data available as fast as possible. And with the help of Spark, then it just goes pretty smooth. It's totally up to us whether you want to create a table on table, view on a table, etc. Like delta table on a delta table is possible, view on a delta table is possible. However, it totally depends on your SLAs when you would like to make that data available. So, but if there is a lot of data, the system is going to use bigger power from the CPUs that are supplied, and it will use the scaling as and when it is needed. And that's the beauty. When you're needing, it's going to scale up. We don't need, it's going to scale down. Now, I think this simple slide, I feel it's just important to see what were the drawbacks of data lake and how they are solved by Delta Lake or a Databricks layer. Like we said, CRUD operations, now you can do. We were looking at the examples, we were trying to write insert statements, update statements, delete statements, and all were possible because of this delta lake layer and the transactional log and Parquet files. ACID transactions, when there is a file problem, you need to keep track of what files are loaded, when are loaded. You're not duplicating the files. You just upload, reloading only the failed ones. All that is possible through a Databricks own architecture, and this is really also possible from a perspective of streaming services like IoT services, where you are pulling data almost near real time. And even if in such cases as well, it can detect what was loaded, what was not loaded, which is really beautiful because for streaming, trust me, it is really hard to keep track of things, which is also happening in the system. Versioning, auditing, delta architecture, all is taken care with the help of magical data layer, so it's supported by Parquet files and transactional logs. And at the end, performance not being good, which was the case in data lake, it is improved much better because of the Spark architecture, and they are improving it day by day basis to make it more and more efficient. Hence, from analytics perspective, this is a win-win situation. Now, if we move, if we look at what services Databricks uses, because nowadays what's happening is there is a trend that all companies are trying to roll out their products, but they also think that, okay, I have a core concept, but why do I have to create all the services from scratch? The hyperscalers are giving more or less all required services these days around security, authorizations, protection, or analytics, etc. So what they do is you have your own core product, and you use all these services to make it complete. And that's what Databricks is doing. In this case, in case of as an example of Azure, they use very standard services from Azure, such as Azure Active Directory. It is used for authentication, user management, etc. You want to protect, of course. You have Azure Blob Storage, where all those Parquet files and the transactional logs are stored. So it's not kind of creating their own storage. It's going to reuse what Azure is giving. There is a virtual network service where you can do network isolation, security controls, etc., etc. Keep Vault to store the secretive or sensitive information into the system. There are lots of times those technical keys that you would like to keep in the key vault. There is Azure Log Analytics that is used for monitoring, logging, and gaining insights into the performance, basically, right? So all in all, there are lots of other services. I've just pointed out few one to give you idea that in general, that's how Databricks works. And when in the journey I was talking about integration with AWS, Azure, or GCP, this is what this integration is about. That you are able to reuse all the services as efficiently as you can. Now, when it comes to the supported language, and that's what I really like about this tool, is they are supporting lots of new languages. They have a very simple Jupyter type notebook interface, and they have SQL editor as well. You can write Python, SQL, R, Scala, Java. Uh, that's your choice, what you would like to do. At the end, you're going to end up with the same results. I personally prefer Python because it has a lot of libraries, especially in ML area, and it's just easy to learn. When I was learning, it was just so much easy for me. It was so much easy for me to kind of get up to speed in this language. And Python also supports writing, or let's say it has a wrapper that allows you to write the SQL queries. So you can create, say, table views through Python by writing SQL statements. Or if you're creating something in Python, as say a temporary view or something, you can also read that in the SQL. So these all languages are a bit more in a way interchange, uh, they're using their own services pretty efficiently together. So that's this really is a good selling point for the Databricks team as well. Now, so there are two parts, right? From a flat files perspective, because as I said, the data is going to be stored as a file always. So in previous architecture, we saw that whatever we do, whatever kind of changes that we are doing, they all are stored as a Parquet file. So that's their internal architecture because you're storing it as a Parquet file, the updated records, the new records, etc. Whatever you are doing. When it comes to processing, so as an example, I have a CSV file. Do I have to every time convert it to Parquet? No. You can just keep that CSV file into, say, Azure Blob on which Databricks is set up, and you can just create a delta table on the top, and everything will work as you want. The magical layer of Delta Lake will come into picture. It will make sure all the delta changes are tracked, everything that just we saw in the architecture. So from that point of view, there is a lot of support towards CSV files, JSON, XML, open formats, Apache Avro. There are, I think, a couple of formats from Apache. From Avro, I think it's a binary data format. It's quite compact and fast. So sometimes people use that. ORC format is also very small and efficient, and it is one of the fastest columnar storage. Especially, I think it has been used aggressively for Hadoop workload. Apache Parquet is evergreen. Like I said, it's columnar and compressed file format, but at the same, even though it is compressed, you're able to query the data very efficiently. Text data and binary files, especially when you have images, right? Converting it to the binary files and loading in the system is quite efficient. So that's when binary format is quite helpful. As now, as like any other tool in the market, you you will have limitations because always it goes back to how your architecture is designed. Databricks do as well. So we have been seeing that it all sits on the flat file. There's a Spark architecture. It's trying to pull the data as and when you need. So, but what happens is, even though you have Spark there, your BI analytics and reporting queries uh, or SQL queries are not as efficient as you would compare with, say, a query. If I write a query on a relational database, so if you are trying to just pull, say, one record out of the system, it's going to probably take a bit longer to pull the data out because it still has to go through whole file set before it comes. It uses caches and other mechanisms to improve that. However, there is always a point where after this it cannot improve further. So there is a minor lag when it comes to that performance. And sometimes it is recognizable, but I still feel this is not a killer limitation. It still works pretty efficiently from my experience. When you have another huge number of reporting users, this may not perform as efficiently as one wants. From a competitor's perspective, DREMU more or less uses similar architecture, uh, and they also have pretty, let's say, a stable tool or a tool set. What they say is that, okay, even though we are using almost same architecture, like a virtual architecture, from virtualization perspective, you're trying to virtualize all the data from a flat files underneath. Because of the caching capacity and their internal algorithms, the user reporting, the limitation that we talked about, Databricks are it's pretty efficient when it compares to the Databricks. So that's what DDMO codes is, that their the reporting analytics capabilities are quite performant. Snowflake is not exactly a competitor because Snowflake more or less deals with a structured data or a semi-structured data. But because Snowflake actually even doesn't do well when it comes to semi-structured data because it slows down, right? And It doesn't quite efficiently support you from a sense of AI ML as a core tool. Of course, they have introduced lots of new add-ons on the basic tool that they have, which gives you all AI ML, even Gen AI support. But at the end, it's not completely a comparison. So what lots of companies do is they install Snowflake for a reporting, end user reporting, and Databricks for ETL purpose. So you load the data, transform, etc., and at the end you supply to the Snowflake for all your reporting capabilities. Google BigQuery is also quite efficient. They crawl through your all files and allows you to report on top of the files in a virtual manner as well. Azure Synapse Analytics is also one of the best in the market. They also use Apache Spark technologies for big data, and they are also allowing you to report on the unstructured and structured data. So there are lots of other competitors. This competition is quite tough. However, I still feel Databricks has quite unique features that makes them stand out in the market. But I think time will tell how all other technologies are advancing in here. I think one thing when we were talking about the structures, uh, you may ask, maybe I can go quickly jump back. We were talking about a limitation that it's always a structured data that a classical database can be processing, right? And Delta Lake somehow helps you to improve that. But here you have been seeing all the structured delta table, like in example we saw sales order was there, all those columns were there. So you are getting a proper structure as an outcome. So how does it support unstructured data as well? So what happens is in future, as an example, if we go back to our drawing, if in future you introduced, say, another column here, I don't know, maybe uh, another quantity multiplied by price is your sales value. If I introduce, say, another column called sales value, and maybe I can draw quickly here, sales value, yeah. And there are lots of values, say, I think it will be 2000 here, and it keeps going at 100 multiplied by 20 is basically a sales value, quantity by price per unit. And you introduce that, what's going to happen is delta table will support you to add new column. The only thing is that you will not have value coming for the historical records, but for the new records you will start getting a sales value as well as output. So really, it it will allow you to transform your tables very efficiently, because at the end this is all virtual. So it's so easy for the system to change the way it needs. The only thing it needs to keep a control on is these virtual layer and transaction log and Parquet files. So at the end, what you see in the delta table all depends on, boils down to these levels. So all these structured, unstructured data quite efficiently works in case of Databricks. Even the images that I was just telling, you can convert those images into binary files and upload in the Databricks and easily decode that. So all in all, this is what I wanted to cover about Databricks with you. I hope it was really helpful. Um, and I'm always there and open to improve. So if you see anything worth changing or adding, it would be it would be interesting, or I'm looking forward to hear that. If you like my channel, please don't forget to subscribe, like, and hit notification icon. Thanks for watching. Uh, we'll see you next time. Thanks. Bye.